Hello engineering students, this is a short explanation or to try to help you understand while loops a little better. In the task main you can see here that I set up all of my sensors and motors just like we would on the test bed. And now I'm going to explain a little bit about a while loop. There's going to be times when we're writing a program where we want that program to always continue or always continue under a certain condition. So if we wanted, say, our left motor to continue running. So we'll just say we want that left motor to continue to run for an infinite, for as long as we have battery or whatever it is. Because right now what would happen is, say for this program, I put in a wait of 5 seconds. And then I stop the motor. I would have a very simple program. Start the motor, wait 5 seconds, stop the motor, my program would be done. Now remember, it reads lines instantaneously, so it's pretty much going to instantaneously start the motor. It's going to look and it's going to instantaneously wait for 5 seconds, and then it'll stop the motor right after that line of code. There will be times where we want something to just continue running. Now if we wanted this program to continually run, what we could do is we could place this in a while loop. So I'll just type in while, and then there's got to be some condition that we're going to meet. So I'm going to talk about this in a second. But the while loop has its own set of parameters, so what it needs is its own set of curly braces. So to make this a little bit understandable, I'm just going to get rid of this pseudocode for right now. But if I just tab over here, you can kind of see the flow of the program. Task main immediately looks at this while. I'm going to write a condition in a second, and they'll continue to run this program. Start the motor, let it run for 5 seconds, then stop the motor, and that will continue to happen as long as this condition is true. Now we can do a lot of things with this condition. So for example, we go back here, we have this Boolean logic. The while can be based off some kind of sensor we have on our board, where 1 equals 1 is true, so it always run, or 0 equals 1 is false, it wouldn't run. We could place any of these in here if we're using potentiometers or any of the analog sensors that can have a greater than or less than value. So for example, a very simple while loop would be a 1 equals 1. What this states is this condition is true, 1 does equal 1, so it's always going to run this. If we have a 0 equal 1, well, this is a false condition, so it will not run the while loop. The while loop has to be a true condition for this to work. So if we wanted to now place this while loop under a parameter, say for like a button, we could say that the sensor value of a, let's see here, what did I name this? Limit switch equals 1. So what I would have is, while the sensor value limit switch equals 1, it would run this program. So on the test bed, I would press the limit switch, and as long as that's running, as long as that limit switch is a 1, this program will run. Now, the only issue with that is that program will actually never run if you hit the start button, because it instantaneously looks at this line, sees that the limit switch is not pressed, and it stops the program. So we'll get into how to fix that later. But say you wanted this to run while pressing, well, like with the limit switch is open, we could just say while the limit switch is 0. So as the limit switch is not pressed, that's a 0. So we talk about that binary, 0s and 1s. As that limit switch is not pressed, so it's giving us a 0 value, this will run. So as soon as we press that limit switch, that would be a 1, and it would stop the motor. You can kind of think of this as like an emergency shutoff for machines. If a machine's running and something happens and you got to quickly shut it down, you hit that button and it will stop that operation, whatever it is. So it's kind of like a while loop. So that's a really simple way to take a look at while loops. You can place almost any type of Boolean logic in there from this PowerPoint. So we could have a not equals to, an equal to. Alright, we could also replace it if we wanted to do this. We could go equal 1. So we could say this another way. This is another way of saying equals equals 0. So we're saying as long as the sensor value limit switch does not equal 1, then it will continue running. But as soon as it equals 1, then it would stop. So this right here is a simple other way of saying that equals 0. Kind of depends which one you want to go with, but there they are. So this is just a real quick tutorial on while loops, how to make them work. I did talk about if you wanted this to be a 1. Well, if you're not holding the limit switch down when the program starts, it's immediately going to see this as a 0 and stop the program. Well, you could actually place this in another while loop. So you can see here I'm tabbing over, so all of my start curly braces and end curly braces are on the same vertical column. So we can just look at this. So now what happens is this program, while 1 equals 1 is a true condition, so it will continually look at this line. It will always continually look at this line. It'll just keep looping back and forth, and as soon as it sees it as a 1, then it's going to run this internal program. So you can have many nested whiles to get what you want. And it's all about programming and manipulating the program and trying to figure out what you want. So, like I said, short tutorial. Hopefully this helps you understand. Please ask questions if you don't fully understand it. This is going to be one of the basic operations you need to understand when creating your marble sorter.